Hello and welcome to another exam paper walkthrough. I'm going to be carrying on with our GCSE maths, and this is an AQA predicted topic paper, and this is paper 2/3H, and this is a good chance paper. I'll explain what I mean fully by that shortly. So attached to the description to this video, you'll find a link to a Google Drive where you can download a copy of this or my very likely paper. I'd strongly recommend you have a go at the good chance paper before watching this video, just to get the most out of it. Or you can do it alongside, whichever works better for you. I'd also recommend a bit of music on in the background just to make the video a bit more enjoyable. This is preparation for the June 25 examination series, and the topic list that I've used here was taken from First Class Maths. They've got some fantastic resources. If you've not checked out their site already, I would strongly recommend that you spend a bit of time there as well. If you find this video useful, please do subscribe if you like, and you'll get notified as soon as my other videos drop, including the very likely paper that I'm producing for this series. So what I mean by that is First Class Maths done some fantastic analysis of the what topics appeared on paper 1 and looked at the historic data and produced a 5-star, 4-star, 3-star, 2-star, 1-star of all the topics that are left to appear. It's no guarantee that they'll be on those, but I've called the 5-star and the 4-star. I've put those topics together and made it into a very likely paper, is what I'm calling it. And I've also made all of their 3-star topics into a good chance paper. I've tried to ask a couple of questions on each of the topics just to make sure we've got a nice spread and cover a few of the skills involved in each of them. That set aside, if you've got any questions, comments, or feedback, please put them into the chat to the video and I'll get back to you fairly quickly. The questions are my own, solutions are my own. So if you spot any mistakes, please do let me know and I'll make a note on it. Okay, so question 1, write 30 to 12 in the form of n to 1. So I'm going to divide both sides by 12. That means that that would give me 1, and 30 over 12 is the same as 5 over 2, because 6 is going to them both. So we'll say 2.5 or 2.5, doesn't really matter. Both will be acceptable. Let's make a decision. I'll go 2.5. Okay, question 2. Two identical quarter circles are cut from a rectangle as shown. Work out the shaded area. So to work out the shaded area, I'm going to treat it as a rectangle. If we're saying that this length here has got to be 6, 6, 6, 6. So we want to do the area of the rectangle, which would be 12 times by 6. And from that, I want to subtract the area of 2 quarters, which would be 1/2. So I want to take away half the area of the circle. So I'm going to say take away pi times by 6 squared, all divided by 2, because I only want half the area. We'll go to our calculator for that. I was just thinking about factorising, because I can take 6 out. But it's a calculator paper, so we'll use our calculator. So this is the model that I'm using. Yours may well be a different model. Anything that's drastically different, I'll discuss. So I want to take away shift pi times by 6 squared divided by 2. That's going to give me 15.45 133 ... So I always before I round, I will tend to write further than I need and then ... So I'm going to go 1 significant figure or 1 decimal place more. So I'm going to go 15.5. Question 3. 3 shops sell the same type and size of lip balm. And we've got shop A, shop B, shop C. We've got various deals and discounts. Which shop is the best value for 8 sticks? And what is the total cost in that shop? Share working to support your answer. So if we start with shop A, typically it's going to be the easiest. We've just no deal at all. So that total price would be £2.39 times by 8. And I'm just going to do some working before I actually bring the calculator up in. So for shop B, buy one, get one half price. So that is going to be 1.5 times by that. And that will give me 2, so I'd need to times by 3. So if I do 3.08 times by 1.5, that would be my deal for getting 2. That would be the price I paid for 2. And I want 4, so I need to times that by 4. And then for shop C, pack of 4 was £11.40, now 1/6 off. So I need 2 lots of the packs, so £11.40 times by 2, but then I want to divide that by, actually, we'll times it by, because 1/6 off, we're paying for 5/6 of the price. Right, now we'll go to the calculator and work them all out. So £2.39 times by 8 gives me a total of, as a decimal, £19.12. For the second one, 3.08 times by 1.5. It's the one there. Times by 1.5 times by 4. That gives me £18.48. And then for shop C, £11.40, so 11.4 times by 2. That's how many times by 5/6. That gives me £19. So the best deal is shop B. So shop B, and the total for that price is £18.48. Right, question 4. Work out giving your answer in standard form. So on a calculator paper, we can just use our calculator for this. So for my numerator, it's really testing the skill that you can actually enter standard form. This is our standard form button here, to the power of 10, and we want to divide that by 3.2 times by 10 to the 4. So that's going to give me that. To give your answer in standard form, so I'm just going to say calc equals 2851234. I'm going to put my decimal point there, so it's going to be equal to 2.85 times by 10 to the, I know I've got 1, 2, 3, 4, 5, 6 to the power 6. So 2.85 times by 10 to the power 6. Right, the scale drawing represents a garden. Water from a sprinkler P reaches 20 meters from P. Water from sprinkler Q reaches 25 meters from Q. Using a pair of compasses, show that the region of water from both show the region that water from both sprinklers reach. Okay, so I'm going to need to take this into a slightly different format, just so I can draw circles. Okay, so if water from sprinkler P reaches 20 meters from P, 20 divided by 5 is 20 divided by 5 is going to give us 4 centimeters. And then 25 divided by 5 is going to give us 5 centimeters. So I want to, from P, do a circle with a radius of 4, and then from circle Q, a radius of 5. So to help me out here slightly, what I'm going to do is, so let's pretend that this is my compass, and actually I want my width to be, let's have it. So I'll make this back into a circle in a minute. So I want 4 centimeters from P, 4 centimeters from P. You'll obviously be doing this with a compass. So that's a circle with, so my compass point would go there. My arms would be 4 centimeters apart. And then I would draw my circle. I'm slightly out here. So that's going to be my circle for my first one. And then from Q, I'm going to do a similar thing. So my compass point, I need my compass arms to be 5 centimeters apart. So they're currently 4, so I'm going to adjust that to 5, and then take this down to 5, this up to 5, and then this needs to go slightly wider. So that's going to be my second circle, just double checking my units there. So that's 5 centimeter circle there. So the region that we're after is, show that the region that both sprinklers reach. So that's going to be that region there. There we go. Okay, right, for question 6, what is 1.75 kilometers as a fraction of 700 meters? So 1.75 kilometers as a fraction of 700 meters. So I'm going to say that it doesn't really matter which one I convert. 1.75 would be 1,750 meters over 700 meters. And then my calculator will do all the simplifying there. So 1750 over 700, 5 over 2. Okay, question 7. Complete the table of values for y is equal to x squared plus 2x. So I'm going to use the table function on my calculator. There's nothing wrong with typing each of these in separately, but the table function is quite useful if you are used to using it. So it gives you the option of typing in two equations. I only want to type in one, so I type that in as alpha x squared plus 2, and I've mistyped there, sorry. So alpha x squared plus 2 lots of x. I don't want my second function. I've got an option of putting the second function in. I want my values to start at -3. I want my table to go up to 1. And I want it to go in steps of 1 because these numbers are going up by 1s. Okay, so that's my completed table. The values that we've already got in, we can just check that we've got this right. So when it's -3, it should be, sorry, when -3 is 3, -2 is 0, -1 is -1, 0 is 0, and then 1 is 3. Draw the graph for the value. So I'm going to make that slightly bigger just so I can do the coordinates. So -3, 3, -2, 0, -1, -1, 0, 0. Oh, I've gone completely out there. -1, -1, 0, 0, then 1, 3. Now, I can't demonstrate this particularly well, but keep your wrist on the inside when drawing a curve, just because you'll draw it smoother. Spinning my device around so I can get my wrist on the inside and draw it semi-smooth. So that's roughly what it's going to look like. Obviously, with a pencil, you should get it a bit smoother than mine, but that's the basics of it. Okay, question 8. The cost of a ticket increases by 10% to £19.25. Find the original. So that means that 10% increase is a multiplier of 1.1. So the original value times by 1.1 is going to be equal to 19.25. So the original value would be 19.25 divided by 1.1, which will give me, so 90, back into mode 1, 19.25 over 1.1. That gives me a value of 17.5, which is a price of £17.50. Question 9, expand. And we've got quite a difficult one to expand. It looks difficult anyway, but it's exactly the same process of expanding anything else. So x squared times by 2x will give you 2x cubed. 2x times by 5y would give you plus 5x squared y. This times this will give us minus 18 x squared y. And then this times by this will give us minus 45 x y squared. So when we collect this together, then we've got two lots of x cubed. These two are the same term, x squared y. So 5 minus 18 is minus 13 x squared y. And then minus 45 x y squared. Okay, work out the lowest common multiple, or LCM, of 120 and 145. So on a calculator paper, I would do it like this. So 100 and... So I put the smaller on top, larger on the bottom, and my calculator will cancel this down for me. And So that's the same as 5 over 6. So what it's cancelled down by is the lowest common the highest common factor. And then you can find the lowest common multiple by times in the numerator by either of the denominator, or the numerator of one by the denominator of the other, or the denominator of the other by the numerator of the other. And they'll give you the same value. So 120 times by 6 gives you 720, or 144 times by 5 also gives you 720. So that's the lowest common multiple. There is a function of highest common factor, lowest common multiple on your calculator, but essentially the mechanics behind it is exactly that. So it will cancel down by the highest common factor. And then you can find the lowest common multiple by times the numerator by the denominator. Right, question 11. 12,600 is equal to, and we've got it in product of primes, and this is a product of prime. Work out the highest common factor of these two numbers. So the highest common factor is whatever they've got in common. Write your answer as an integer. So they want the number, not the index form. So the highest common factor is going to be equal to, they both have 2 to the power 3 in common. They both also have 3 squared in common. They also both have a 7 in common. So that will be our highest common factor. 2 cubed times by 3 squared times by 7. Just double check that. So 2 cubed, 3 squared, and 7 are their common factors. So 504. Right, question 12. A building company employs 2 labourers, 14 joiners, 9 electricians, and 8 plumbers. For a job, the company needs 1 of each type of worker. In how many ways can the company choose 4 workers? So this is going to be 2 times by 14 times by 9 times by 8. Right, 2 times by 14 times by 9 times by 8 gives us 2016 possible combinations. Part B, 1 labourer and 2 plumbers are on holiday. How many ways can the company now choose? So we've only got 1 labourer. Yeah, I was just trying to work out whether I could adjust this number, and I can. So I could divide by 2 and then divide by 2, 3. But we'll stick with the original. So 1 labourer, we've got 14 joiners, we've got 9 electricians, but now we've only got 6 plumbers. So 1 times 14 times by 9 times by 6, that gives us 756 combinations. Okay, question 13. The length of each side of a regular pentagon is 8.4 centimeters to 1 decimal place. Complete the error interval for the length of one side. So the length of one side, if we've gone, I'll actually do it here, 8.4 as opposed to 8.3 or as opposed to 8.5. That means that our middle value that we're going to put here is going to be 8.35. And our upper value, which it does actually have to be less than, is going to be 8.45. Right, complete the error interval for the perimeter. So we're going to take the lower bound, 8.35, and what were we looking at? A pentagon, so we've got to times that by 5, and then 8.45 times by 5. Although I think we can just say it's going to be 1. Yeah, we'll do that though. 8.35 is times by 5. That's going to give us, as a decimal, 41 point, I missed what that was, 75. And I was just thinking to myself, the difference between those is 0.1. So we could say the difference is going to be 0.1 times 5, so it should be 0.5 bigger. So we could just add 0.5 on. 42.25. However, I'm just going to check that. I've got a slight blank that I might have done that wrong. So yeah, we get that both ways. Right, question 14, work out the area of the trapezium. Right, so it's a bit disguised, but we need to work out the height of the trapezium, so I'm going to put that here. If this side is 11 and this side is 15, then this length here must be 4. So we're going to use a bit of trig here. I'll change colour. So if this is the angle I'm working with, this is going to be the opposite side, and this would be the adjacent side. So we're going to be using our tan ratio to work out the height. If tan is equal to opposite over adjacent, then if I rearrange it to find the opposite is going to be equal to tan of the angle times by the adjacent side. So the height of the trapezium, so I'm not really happy with my notation there. Let's put it as a lowercase h. Just because it's my little idiot, there's my school bell. It's my little habit. I always try to put trig letters in capitals, and then so the length should be h, not capital H. So I'm looking at tan of 64 times by the adjacent side, so times by 4. Just double checking that. Right, so the height of that, and I'm going to leave it there because I'm actually going to use that value in this and not round. So the area of the trapezium is going to be equal to a half of 11 plus 15 times by lowercase h. Right, so tan of the angle, which was 64, times by the height, which would be 4, is equal to 8.2012 dot dot dot, and I'm not going to round that. I'm going to use that value here, so I want to do a half, so I'm going to just say 0.5 times by 11 plus 15, which would be 26, times by my last answer. So that gives me 106.615 dot dot dot. So I'm going to go just to one decimal place, 1 degree more accurate than the question. So I'm going to go 106.6, and we've got the unit there. Right, question 15. Here is a sketch of a curve. The curve is x squared minus 4x minus 5. Write down the two roots. So the two roots are where it crosses the x-axis. So we've got minus 1 and 5. Work out the coordinate of the turning point. Okay, so for the coordinate of the turning point, what we really need to do is complete the square. So if I call the equation y is going to be equal to x squared minus 4x minus 5. So if I complete the square, that would give me x minus 2 all squared. I'd need to subtract minus 2 squared, so minus 4 minus 5. So that would give me x minus 2 all squared minus 9. Meaning that my turning point is when x is equal to 2 to make that bracket 0, and y would be equal to minus 9. Right, question 16. Mass of an ornament is m grams, height of the ornament is h. M is directly proportional to the cube of h. M is equal to 1,600 and h is equal to 8. Work out an equation connecting m and h. Right, so m is directly proportional to the cube of h. That means m is equal to k times by h cubed. So we're going to use this initial situation to work out our equation. So 1,600 is going to be equal to k times by 8 cubed. Rearranging that, then k is going to be equal to 1,600 divided by 8 cubed. So that gives us 1,600 divided by 8 cubed. Gives us 25 over 8. We could go decimal, although it's not overly nice. So I'm going to leave it as that fraction. So let's go back to that. So that means then that m is equal to 25 over 8k cubed. Work out the mass of the ornament when the height is 12 centimeters. So m is going to be equal to 25 over 8 times by 12 cubed. Already got that there, so we're going to just times by 12 cubed. So the height should be 5,400 to say in centimeters, so just double checking my units. Yeah, height in grams, yeah, so we're looking at 5,400 grams. Right, question 17. Barbie thinks that E and D are linked by the equation E is equal to 36 over D. The graph shows the value of D and E for D is less than or equal to D, 2 is less than or equal to D, which is less than or equal to 6. Choose one point on the graph and state if Barbie's equation is correct for that point. So I'm going to look for as nice a point as I can. I haven't got a lovely one anywhere. I'm going to go for the starting point. Choose one point on the graph. So I'm going to keep it nice and simple. I'm going to use the starting point. That is the coordinate 2, 15, 16, 17, 18, 2, 18. Right. And stated Barbie's equation is true for that point. So let's work out E then. So this is D, this is E. So if it is correct, then 36 divided by 2 would be equal to 18. So it would be true. So is correct for that point. Question 18. G is directly proportional to the square root of h. G to h is 3 to 2 when h is equal to 16. Work out G to h when h is equal to 100. Okay, so I'm going to start with the ratio G to h of 3 to 2. So I'm going to find out the value of G when h is 16. To get from there to there, I'm going to times by 8. So I'll do the same here. So that will give me 24 to 16. So when G is 24, H is equal to 16. Now, if I go to, I'm going to keep the ratio method for direct proportion. If you're not happy with that, you can use the equation of proportionality with this as your initial value. So G is directly proportional to root H. So if I put these two values in, I've got 24 to the square root of 16, which is 4, 24 to 4. Right, these numbers are now proportional. So if I want to build that up to the square root of 100, which is 10, I'm going to say that that's going to be the same as the ratio 12 to 2, and then times it by 5. So it's going to be 60 times by 5 times by 5. So we've got the ratio of, that means 60 to 100, square root of 100. So that's our values for G and H then. So H is 100. 100 is 10. Yeah. So if I want to then come back to this ratio, I want the ratio of G to H with these values. So we've got 60 to 100, which is the same as go 3 to 10. 6 to 10, 3 to 5. So I'll go do that as my jump. 6 to 10, 3 to 5. So my ratio is going to be 3 to 5. I'll include the proportion equation here. So pull that method 1. And I'll do method 2 just down here. So method 2. So we've got and you can see the links really. G is equal to K times root H, and we found this initial value. So 24 is going to be equal to K times root 16, so 4. So K is going to be equal to 6. Right, when H is 100, then G is going to be equal to 6 times by the root of 100, which would be 60. So, and then you'd follow that method from there. So that's just the second method for finding the 60. Question 19. Here are the results for 250 spins of a coin. The coin is spun an extra 50 times. After all 300 spinners, the relative frequency of heads is 0.49. For the extra 50 spinners, work out the number of heads to the number of tails. Okay, so this is based on 250 trials. If we say the relative frequency of the heads after the new one, after 300, is 0.49, we're going to work out what that value would be then. So I want to do 300 times by 0.49. So 300 times by 0.49 gives me 175. 147, sorry. So 147 now. So the difference then, is 147 minus 122. So we've got, out of that, we've got 25 extra. So for the extra spinner, for the extra 50 spins, that's definitely right. There we go. So apologies, I made a minor mistake there. I typed in 120 to my wrong value. So I'm doing 147 minus 128, which gives us 19. So that should have been 19, difference of 19. Which means we don't need to work out that total. If it was done 50 times, that would mean we've got 31 there. Right, so number of heads then, just checking I've got this the right way around. So we're looking at 19 to 31. Question 20. A, B, and C are points on a circle of center O, so A, B, C. DC is the tangent. Show that angle AOB to ACO is 3 to 1. Right, so let's label the two angles that we're talking about then. So ABO is that angle there. So I'll call that X for now. And we want ACO, so A to C to O, that angle there. Okay, so to show that, so we don't need to state our reasons. So I'm going to say, I'll make it clear though. So ABC is going to be equal to 83. First of all, I'm going to say, so I guess I can label that 83 because that is the alternate segment theorem. We are also going to say then we can work out this angle here. We'll do that in a moment though. We can say that that angle there is going to be, so BAC is going to be equal to 2 times by 28, because angle at center is twice angle at circumference, so that's going to be 56. We've got an equilateral triangle there, so I'll say that angle OBC is equal to angle OCB, and they're both going to be equal to 180, the angles in a triangle, minus 56 divided by 2. So both those angles are going to be 180 minus 56 divided by 2. So we're looking at 62. Right, so we can work out angle, so ABO, is going to be equal to 83 minus 62, so that's going to be equal to 21. We'll just double check that though. 83 minus 62 is 21. Right, so I've got that angle. That's nice because it is divisible by 3. Right, so I'm also going to say that that must be a right angle. So y is going to be equal, I'll call it by its proper name. So OCA is going to be equal to 90 minus 83, which is going to be equal to 7. Reason for that is the tangent and the radius make a 90-degree angle. So we've got as a ratio 21 to 7. So 21 to 7, and then both of those numbers are divisible by 7. So that's going to be 3 to 1. Question 21, simplify fully. So I'm going to do a bit of diagonal cancelling here. Let's make it a bit bigger. Right. So what I can do is I can cancel those C's straight away. I can cancel 2 of the B's as well. So that's going to leave, and I can cancel an A. That's going to give me A squared as my numerator and DB cubed as my denominator. So we'll go A squared over DB cubed. We could do that as a to the power 2, b to the power minus 3, d to the power minus 1. That would be okay as well. We'll leave it like that though. Right, question 22. So we've got xn plus 1 is equal to the cube root of 3xn plus 7. Use the starting value of x1 is equal to 2. Work out the solution for, give your answer to 3 decimal places. Okay, so what I'm going to do here is I'm going to use my calculator and I'm going to press 2 equals. I'm then going to type in my iterative formula as the cube root of 3x plus 7. And I'm going to carry on until I get a repeating 3 decimal place digit, if that makes sense. So I'll actually state what they are. So x1 is equal to 2. x2 is equal to x3 is equal to x4 is equal to. Now technically I can probably I don't really need to show these. I just need my answer. But for 3 marks it's useful to show. Right, so I want to go the cube root of, so the cube root of 3 lots of my answer plus 7. Now, so that's going to be x2, so 2.3511133. If my next answer would round to the same 3 digits, 3 decimal places, I could stop. My next value doesn't though, so we've got 2.41323 dot dot dot. And again, if it rounds, my next value rounds to the same, it doesn't, but it rounds to the next 2. So we've got 2.4238 dot dot dot. So x5 is going to be equal to, we're getting closer now, 2.4256 dot 6 dot dot dot. X6 is going to be equal to, we can, oh yeah, we can stop here. So 2.4259, and these 2 values will both round to the same 3 digits, even though it's not actually the same 3. So they will both round to 2.426, so we can stop there. Right, question 23. Write x times by 3x minus 9 is equal to 4 in the form where a, b, and c are integers. Okay, so that will give us 3x squared minus 9x minus 4 is equal to 0. So that's our values, 3x squared minus 9x minus 4. So I've expanded the bracket and taken the 4 over to the other side. Right, solve and give your answer to 2 decimal places. This is prime really for the formula. So the formula is going to be the way that you should go. I'm going to try and be a bit fancy for myself. I'm going to complete the square. So I'm going to take a factor of... No, I'm not. My issue with completing the square is if I first of all factorize the first term, could complete the square here, but it's awkward with it not being a prime, with it not being an even number. So we'll go for the formula. So I'm looking at substituting into x is going to be equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Right, so minus b would become 9 plus or minus the square root of 9 squared is 81 minus 4 lots of 3 times minus 4, all divided by 2 lots of 4, 2 lots of 3, all divided by 6. Right, and I'm going to type it in just like that. So 9, I'm going to go the negative one first of all, the square root of 81 minus 4 times 3 times minus 4, all divided by 6. And then that should simplify for me nicely. Well, not nicely, but so we've got 9 plus or minus the square root of 120. What was that? 129. 129 over 6. Right. So if I go for the decimal then, so my first value then is going to be minus 2 decimal places, minus 0.39, and then my other value is just going to be, if I replay this and change that to subtraction to addition, and as a decimal that's going to be 3.39. Right, question 24. Solve x squared plus 7x minus 11 is equal to 0. Give your solution as decimals. So again, I've just done a quadratic formula, so I'm going to do this by completing the square. So to do that, I'm going to say that that's going to be x plus half of this coefficient, so 7 over 2, all squared. From that, I need to subtract this term squared, which would be 49 over 4. And I've still got minus 11. I'm going to write minus 11 as minus 44 over 4, just pre-planning that I'm going to be combining them. 0 at the moment. So I'm going to combine those two together. That's going to give me 93. And I'm going to take it over to the other side. So x plus 7 over 2 all squared is going to be equal to 93 over 4. Now if I square root both sides and take this coefficient over, this term over, that will give me x is equal to minus 7 over 2, and then the square root of this would be 2 on the denominator, so, which is what I've combined there. So plus or minus root 93. And then I want my positive and negative value of that. Right, so if I type it in just like that, so minus 7, we'll go for the negative one first of all, square root of 93. All over 2 is going to give me, first of all, minus 8.3218 dot dot dot, and then we'll go or, and then if I change the subtraction to a addition, my second value would be 1.3218 dot dot dot. Right, it doesn't state the degree of accuracy. I will always go one more than the question, so to 1 decimal place or one more significant figure. So I'll go to 3 significant figures. So minus 8.32 or 1.32. Right, question 25. 4y is equal to 5x. Which statement is correct? Y is, X is, X is. So if I rearrange this slightly, so I'll say Y is equal to 5 over 4x. So Y is equal to 1.25x. And if I do it the opposite way around, X is going to be equal to 4/5 of Y. So X is going to be equal to 0.8 times Y. So I would go. So the only one that fits here, so this would be 125%. So Y is 125% of X. I was tempted with, no, none of the others will work. We could say that X is 80% of Y, but that's not one of our options. Question 26, write as a single fraction. In its simplest form. Right, so I'm going to kind of cross multiply here. Yeah, so I'm going to put them all over the same denominator. That denominator is going to be 10a squared. Right, to do that, I'm going to have to times this fraction by this numerator by 5, so that would give me 35, and I need to times this numerator by 2a, so that would become 6a. So there we go. So we've got 35 minus 6a all over 10a squared. Okay, question 27. Basketball team plays 19 home games and 19 away games. The box plot shows the information about the team scored in the home games. Here are the points that the team scored in 19 away games. And they're arranged in size order, which is quite nice. On the grid, draw the box plot for the away games. Right, so for this, if we've got 19 scores, to find where the median or the position of the median, what we're going to do is 19 plus 1 divided by 2 is going to give us 10. So our median, well, our lower quartile will be the 5th. Our median will be the 10th value. And our upper quartile will be at the 15th value. So 1, 2, 3, 4, 5, we need that value. 6, 7, 8, 9, 10, we need that value. We'll go backwards. 1, 2, 3, 4, 5, we need that value. So those are the values that we're going to be using. We're also going to be using the smallest value and the largest value, and that's what we need for our box and whisker, well, our box plot. Right, so we're going 85, we're going 96, we're going 99, and then upper quartile 109, and maximum value was 126. We make that into our box, and then these branches are often referred to as the whiskers. Okay, on average, did the team score more points in the home games or the away games? Use one statistical measure. So the statistical measure we'll use is the median. So they scored more in the home games. So they scored on average more in the home games using the median. And I'll just show what the two medians are. We've got 106 versus 99. So 106 versus 99. Okay, part C. Was the number of points scored more consistent in the home games or the away games? So, consistency is going to be referred to, we're going to use the interquartile range. That's in a sense, the difference between the start of the box and the end of the box. This box is 20, 22, 5, 10, 15, 20, 22. And this one is 5, 10, 13. So they were more consistent at the away games. They were more consistent at away games using the interquartile range. And then we'll say that was 22 versus 13. Right, question 8. VABCD is a pyramid with a horizontal square base. X is the center of the base, and V is vertically above the center. The distance A to D, so that would be that distance there, is 13. And the angle VBX, VBX, so that's that angle there, is 72. Work out the length of VB. So we want this length here, which I'll call X for now. Right. I've got a right angle triangle there. I'm going to redraw it just to make that a bit clearer though. If that length there is 18, I've written 13 there, 18, this length here must be 9, half of that. That's our X, and we want to work out that's 72. So we're going to be using trig, so this is going to be H, the hypotenuse, this is going to be the adjacent. So we're going to be using the cos ratio here, so CAH. And we want to work out the H, so if I rearrange that, H is going to be equal to A divided by C. And then if I substitute in, X is going to be equal to 9 divided by cos of 72, which is going to be, right, we'll get our calculator up then. Let me just move my sheet over slightly so I can type and still see. So 9 over cos of 72. So we're looking at 29.1246 dot dot dot. Right, the question has either, I always go 1 degree more accurate than the question, so that would either be 1 extra decimal place or 1 extra significant figure. And normally, in most cases, it ends up being the same value for both, either to 1 decimal place or 3 significant figures. That would be 29.1. Right, question 29. Here are 2 square paving stones. The stones are similar solids. So that means that we've got a constant scale factor between them. The price per centimetre cubed is the same for both stones. The larger one is priced at £17.50. Work out the price of the smaller one. Right, so we're going larger to smaller. So if I want my scale factor of larger to smaller, my scale factor for length is going to be equal to 20 over 25, which will be the same as 4/5. Right, so the scale factor for length will be 4/5, which means that the scale factor for volume is going to be that value cubed. So if I want to work out the price is going to be equal to, because it's related to the volume, the price then is going to be £17.50 multiplied by the volume scale factor, so 4/5 cubed. I'm going to type it in like that. 17.5 times, point out 17.5 times by Just to make it easier, I'm going to go 0.8 because that would be 4/5. It saves me having to deal with the fraction button. So we're going to have £8.96. Right, question 30. Here is the plan of the floor of an L-shaped room. All lengths are in meters. The area of the floor is 75 meters cubed. Show that. So we need to break this down. We've got a composite shape, so we need to break it down or build it up and take away. I think building it up and taking it away is the easiest option here. So what I'm going to do is I'm going to say the area of the full rectangle, take away this cutout. So the area is going to be the two lengths times together, so that would be x times by x plus 1. And then from that, we need to subtract 3 times 5. And that area has to be equal to 75. Meaning then that x squared plus x minus 15 is equal to 75. Then if we take 75 away from both sides, we get x squared plus x minus 90 is equal to 0. And there we go, that's what it has to show. Part B, by factorising x squared plus x minus 90, work out the value of x. You must show your working. So we're going to put that into two brackets. Both brackets are going to start with an x. And then we're looking for two numbers that multiply together to make minus 90 and that add together to make 1. So my only option there is going to be 10 and minus 9, so plus 10 and minus 9, which gives me two values for x. Either x is equal to make that bracket 0, x would be minus 10. To make that bracket 0, x would need to be equal to 9. We can't have a negative length, so we're going to go for this as our answer. So x is equal to 9. Right, question 31. Bag contains discs. We've got a trial. Disc is chosen at random from the bag. Colour of the disc is noted. The disc is put back in the bag. Trial is carried out 100 times. The table shows the relative frequency of blue disc after every 25 trials. So first 25, second 25. First 25, first 50, first 75, first 100. From the trials, for the trials from 26 to 50, so that's this one. How many times was a blue disc chosen? Okay, so we need to do 50 times by 0.36 will give us the number of blue discs that have happened over the first 50. From that, I want to take the number of blues that happened in the first 25. I'm just going to type it in like that. So 450 times by 0.36 minus 25 times by 0.4. It gives me 8. So 8 blue discs happened in that second set of 25. There's a total of 1,000 discs in the bag. Work out the best estimate for the number of blue discs in the bag. So the best estimate is going to be found by using the relative frequency after 100 trials. So I'm going to do 1,000 multiplied by that relative frequency, so 0.32. So 1,000 times by 0.32 is going to give us 320. Just want to double check in my head that we're consistent with blue all the way through. We are, yeah. Sometimes they'll ask best estimate for the number of different colour. And you'd need to kind of do 1 minus the relative frequency or work out that and then subtract it from 1,000, but not in this case. Right, question 32. A boat sails 35 kilometres north from A to B. From B, the boat sails to C and then back to A. Show that the distance the boat sails from C to A is 79 kilometres to the nearest kilometre. You must show your working. Right, so we're going to start by saying this angle here must be 100 because angles along the straight line need to equal 100. And then we're going to be using the cosine rule, I think. We've got non-right angle triangle. We've got two lengths and the included angle. So we can use the cosine rule. So x squared is going to be equal to 35 squared plus 65 squared minus 2 lots of 35 times 65 times of the angle, which is 100. Right, so 35 squared plus 65 squared minus 2 times 35 times by 65 minus cos of 100. Right, so that gives us 900. That doesn't look right. Let's just check that I've typed everything in right. There, I've made a mistake. So that should be not minus cos, that should be times cos. There we go, that's more like it. So 6,240.099 ... no rounding shown. So we want the square root of that, and that should be, there we go. So we've got 78.99 for ... which is 79 kilometers to nearest kilometer. Okay. Part B, work out the bearing of A from C. So A from C, so we want this bearing here. Okay, we know that this angle here is going to be 100 degrees, but we can't do the bearing until we worked out this angle here, which I'm going to call Y for now. Right, the information that we have then, so in an ideal world, I wouldn't use this X value. However, part A is quite crafty in that we know that this is the correct value because it's rounded to 79, which is what we're asked to show, or we could use the 79. So we can use this value. So we've got, this is going to lead to the sine rule because we've got opposite side and angle, opposite side and angle. So we're going to say that sine y over 35 is going to be equal to the sine of 100 over x. I'm not going to write x down. I'm going to leave it because I've got it here. So I'm going to use that fact. So I'm going to rearrange this and I'm missing out a step here, but I'm sure you'll be able to follow it. So y is going to be equal to sine to the minus 1 of 35 sine 100 divided by x. Right, so I'm just going to type it in like that. So shift sine, fraction, my numerator is going to be 35 times by sine of 100. And my denominator is going to be the last answer that my calculator had. Close my bracket, that gives me 25.8705 ... So like I was saying up here, I'll do it again. So C is going to be equal to, angles around a point would be 360 minus these two known angles now. So the bearing is going to be equal to 360 minus 100 plus y, which is going to be equal to, so 360 minus 100 plus my last answer. And that gives me 234.1294 ... So my bearing is 3 figures, 2, 3, 4. Right, question 23. A straight line is perpendicular to the straight line root 2, 8 and 6, 15 and passes through 0, 9 and x 17. Work out the value of x. Right, so the first thing I'm going to do is work out the gradient of this line. So that's going to be 15 minus 8, difference in y, divided by difference in x, 6 minus 2. So that's going to be 7 over 4. which means that the perpendicular gradient, so I'll go perp m is going to be equal to the negative reciprocal, so minus 4 over 7. Right, so our straight line then has to form y is equal to mx, so minus 4 over 7 x plus c. And we know that it passes through the point 0, 9, so that's nice because that actually gives us the intercept. So our equation of our line is going to be y is equal to minus 4 over 7x plus 9. And we want to work out the value of x when y is 17. So if I put 17 in here, so 17 is going to be equal to minus 4/7 x plus 9. So if I minus 9 from both sides, so that would give me 8 is going to be equal to minus 4/7 of x. So if I times that by 7 and divide it by minus 4, so minus 8 times 7 over 4 is going to be equal to x, and then that will give us minus 2, so that's just going to be x is equal to minus 14. Okay, question 34. Chocolate box is in the shape of a prism, is being designed. All lengths are in centimeters. The cross section is a regular hexagon with sides of x and a length of 5x. An expression for the area of the cross section is 3 root 3 over 2x squared. Total surface area of the box must be less than 650. Work out the largest possible integer value for x. Right, so if this is the cross section, the total surface area is going to be equal to 2 lots of that, so the front face and the back face, so 2 lots of 3 root 3 over 2, plus 6 lots of the area of one of the rectangles, so that would be 6 times by x times by 5x. Right, tidy this up a bit, so those would cancel, so that would be, and I missed my x squared there, so that would be 3 root 3 x squared plus 30 x squared. Right, so we know that this needs to be less than, so what I'm going to do is I'm going to write it by factorising the x squared out, so 3 root 3 plus 30. And that has to be, sorry, that has to be less than 650. Right, so if I divide both sides by this bracket, I would get that x squared has to be greater than 650 divided by 3 root 3 plus 30. So that's going to give us a value for x squared. So x squared has to be less than so that gives me a value of 18.467 dot dot dot. So typically speaking, when we square root a inequality, what it actually does is it changes our range quite significantly because we have a negative value that we need to think about. But because we're talking about a length here, I don't need to worry about that. So I can just square root this answer. So if I just square root the answer, I'm going to have that x needs to be less than 2.297 dot dot dot, although technically there would also be x has to be greater than minus 2.297, but we can ignore that. We don't need to worry about it. So, and I've miswritten there, that should have been 4.297. Right, so x has to be less than that. It also has to be an integer, so my answer needs to be 4. Right, question 35. Two congruent parallelograms PQRV and VRFP are joined together. So congruent, same size and shape. X is the midpoint of VT, so we've got an even split there. And V to W, W to R is 1 to 2, so kind of I'll put a 1 and a 2 there, just a ratio like that. Prove that QWX lies on a straight line. So this is what we want to prove. So what I'm going to try to do, doesn't look particularly straight from the diagram, but that's okay. What I'm going to do is I'm going to look at the vector Q to W, and I'm going to look at the vector Q to X, and then provided they're a multiple of each other, so we can take out a factor and make them the same, essentially. They must be on a straight line. Right, so Q to W, I'm going to go along this path. So is going to be equal to Q to R plus R to V. R to W, sorry. Right, so that's going to be equal to Q to R is going to be B, and then R to W is going to be 2/3 of A. Right, I'm just going to rewrite that slightly as I find it easier to keep them in alphabetical order. Right, now if I look at Q to R, so Q to X is going to be, so I'm going to go this way. It's going to be equal to A plus B plus a half B, so plus 1.5 B. So I'll put plus 3/2B. I've not explained that particularly well, so let me sort that out. So I'm going to say that it is Q to R followed by Q to, I'll go straight Q to, I'll go P to X. Right, so Q to R is going to be equal to A, and then P to X is going to be equal to what we said was 1.5, so I'm going to call that 3/2, 3/2B. Right, so I'm going to try and factorize one of these. The one that I'm going to factorize is this one, and I'm going to take, so what I want is, I'm going to take 2/3 out as a common factor, as a factor, and I'm going to manipulate it a little bit, because that gives me an A here, which is what I want for this. So, what would I need to times 2/3 by to get 1? And that's from our knowledge of reciprocals, we should know that 2/3 times by 3/2 will give us 1. So that would be 3/2B. Right, from here then, we've got the same vector there and there. So we can now say that Q to W is equal to 2/3 of Q to X. And now, so that means that, so Q, W, and X must be on a line. A line. QW is a multiple of QX. Okay, question 36 then. So that when x is not equal to 0, 8x squared minus 8, all divided by 4x plus 4, can be simplified in the form ax plus b, where a and b are integers. So for this, what I'm going to do is I'm going to factorize the numerator first of all. I'm going to take out a factor of 8, and I'm going to say that's going to leave me with x squared minus 1, which is the difference of 2 squares, so it would be x plus 1 times by x minus 1. Right, if I try and factorize the bottom line now, so I'm going to take out a factor of 4, and that's just going to be x plus 1. So those would cancel out, and also I can take a factor of 4 out. So that's just going to leave me with 2 lots of x minus 1, which would be 2x minus 2, which is what we're asked to show. Right, question 37. Lizzie runs an 80-meter race in 14 seconds. During the first 6 seconds, her speed increases at a constant rate. That's this section here of the graph. During the last 8 seconds, her speed increases at a different constant rate. Her speed at 14 seconds is 2 meters per second more than her speed at 6 seconds. Okay, so that just means that we've got an increase between there and there of 2 in terms of speed. Work out her acceleration during the last 8 seconds. So during this section, so acceleration is equal to speed divided by time. Her speed has increased by 2 in a time frame of 6 to 14, so in a time frame of 8. So we're looking at a quarter there. I'm going to go 0.25, but a quarter would be absolutely fine. And my unit then is going to be meters per second squared. Right, part B. When Lizzie finishes the 800-meter race, her speed is v meters per second. Work out the value of v. Right, so this speed here, this maximum speed, which I've not drawn particularly well there, is v. The speed here is then v minus 2. And we're going to work out the total area of the graph needs to be equal to 80. So I'm going to work them out. So A1 plus A2 must be equal to 80. Right, so first of all, we've got a triangle. So A1 would be a triangle that is 6 wide, and the height is going to be v minus 2. And then the second shape is a trapezium, which is going to be a half of v minus 2. Don't really need the bracket there, plus v times by 8. And that's going to be equal to 80. So if I do half of 6 first of all, that's going to give me 3 lots of v minus 2. Plus half of 8 would be the sensible one. So that would leave me with 4 lots of 2v minus 2. And that's equal to 80. Right, so that leaves me with, if I collect my like terms, so 3v plus 8v would be 11v. And then minus 6 minus 8 is going to be minus 14 is equal to 80. So 11v is going to be equal to 94. So v is going to be equal to 94 over 11, which is going to be 11 will go into 94 fully 8 times with 6 left over. So I'm going to go 8 and 6/11. Perfectly acceptable to go decimal though, particularly on a calculator paper. Okay, that brings us to the end of the paper. Right, before I sign off, I'll bring up the Q&A just to discuss that briefly. Okay, and this is the question level analysis. So these are the topics of all of the questions. And that gives you the rough mark for the paper was 119. I think it was slightly higher in the end, just because there were a few bits of questions that were included. And you've got the rough grade boundaries of students who sat the questions originally. If you compile all their data together, that's the rough grade boundaries. And you can see that the question, after I'd selected all of my questions that I wanted to use, I arranged it by order of, I think I actually used the grade 6 as my benchmark and kind of awarded them in difficulty that students found that. But that holds fairly uniform. You can see the similar pattern throughout. Thank you very much for your time and watching the video. I hope you found it useful. If you found a question particularly challenging, those are the topics that each question linked to. You can kind of work it out from there. Put in a little bit of extra work on that before your actual exam. Also, strongly recommend you give my very likely paper a go as well. That video will be up, should be up, depends when you're watching the video really. It should be up over the next few days. If you found it useful, please do subscribe and if you like. Any questions, comments or feedback, please put them into the chat to the video and I'll get back to you fairly quickly. Thanks again for watching and I will see you soon.